Then we have the complementary color contrast, where you pick something directly across on the color wheel. And then this is a really interesting one. This is a simultaneous color contrast. This is used by Van Gogh. This is used by the Impressionists. And what happens is you pick something just off. Okay, you pick something just off that color, the complementary color, and your eye will try and superimpose the complementary color. And what happens is your eye-brain system then starts to mix the color. It makes the color exceedingly vibrant. It also makes all the borders very fuzzy. So that's a really interesting color contrast. You can do saturation, where a color is surrounded by a less pure color, and extension, where you have one very bright color and then you have this other color surrounding it, and this is kind of balanced by area. So you can make images using any of these color contrasts. Hubble Heritage Project and other institutes, what happens is we don't make montages. And so here we have a bunch of galaxies, but that's what you would see in the sky if you looked at it through a telescope. So this is a real cluster of galaxies, or group of galaxies, and it's not a montage. And what I'd like you to think about is your own relationship to the rest of the community. If you're working for an institute, perhaps your colleagues don't want you to do some cutting and pasting. But if you are just representing yourself, perhaps you want to get really creative and really artsy and try something else. But if you're looking at a Hubble Heritage image, we use the techniques of black and white photography, traditional darkroom photography that's just been translated into the electronic age, and we didn't do any cutting and pasting. Motivation for using literacy, visual literacy in astronomy images. Black and white images are combined into color images. They're meant to illustrate the physical characteristics and processes and to pique the public's interest. And so this helps you illustrate those physical processes. We don't try and create a one-to-one analog with visual reality. It's not the goal of the person who is making those kind of contour plot-like images, who is an astronomer and trying to get their science across. So it doesn't have to be our goal either. But we don't need to lose the scientific content. In this image, for example, all of the supernovae turn out to be warm colored, and we can distinguish actually their spectral index. So we don't have to lose the information. In this one here, we have the blue and warm colored data, which lets you know this is actually colored on velocity. Okay, so you can see the flow of gas. Hi, Alex. You can see the flow of that gas from the plane of the Milky Way galaxy into the mushroom cloud here. The next ones are also based on velocity. This one won the NRAO competition, image competition, and it's also colored on velocity. So it's gas again. And this is also an expanding gas shell. At the edge, that's blue is coming towards you. This is not released yet. This is the Planck deep field from the Dillingen Radio Astrophysical Observatory. Shows the turbulence again in the gas. So you don't have to lose the scientific information even if you choose to use complementary colors and make a harmonious image. This is just where that planetary nebula is. It's in a globular cluster, and you can see all the warm and cooler stars in that image. And here's another image where, again, the H2 regions here are these sorts of colors, and the supernova remnants are warmer colors. For a summary, the culture of science has a very strong impact, and that's what you're very familiar with, right? So what we want to do is balance that when we're making public outreach images, and especially during the International Year of Astronomy. It might be a good idea to also work in teams. It'd be great to work with people from the RASC. And what we should probably try to do is represent the science in your data and not what the eye would see. And you can also use it during this year to emphasize an experience that you have when you work on your data and share that experience with others. I hope you've learned something here so that you can use visual grammar in order to pique the interest of the public, have them look at your image for longer. You may consider limiting the manipulation, but if you're not representing an institution and only representing yourself, go wild, have fun. Hopefully this will also provide insight to your research and to the pure pleasure of doing public astronomy. Last slide. In the battle between the culture of science and the culture of art, while making public outreach images, both sides win. Here's where you submit your images. Okay, this is for the Canadian Image Curatorial Team for the International Year of Astronomy. Good luck and have fun.